Hello, this is Vedat from Programmership. In this chapter, we are gonna see the second solid principle, which is open-close principle, also known as OCP. This principle basically states a class or a structure or a method, etc. should be open for extension but closed for modification. So to make our code OCP friendly, we shouldn't make changes in our code. On the other hand, we can extend the code for improvements. It is always better to see that in an example. Suppose we are running a transportation business. We have vehicles that carry goods from one place to another place. And let's say we have two kinds of transportation. First one is by truck and the other one is by ship. Now I will make a basic demonstration of this business with some codes. Let's create an enum for transportation types. I'm gonna say enum transportation types. And in this enum, I will add two cases. First one is, let's say, by truck, and the other case is by ship. So these are my transportation types. Also, let's say types. And now I will add my vehicle class. Let's say class truck. And inside this truck, I will create a function called start transportation. And inside this function, let's basically print transported by truck. I will also add another class for my ship. Paste it here and say ship. Also, let's change here ship. Just like that. So to handle transportation, I will add a factory class. Let's also say class transportation factory. And inside this class, I will add two properties. First one will be for my truck, and this will be the instance of truck class. The other one will be for my ship. This is also an instance of ship class. And in the next line, I will just create a function called start transportation. Also, this function will need a parameter, let's say targets, or let's say vehicle type. Type will be transportation types enum, just like that. And inside the function, I will create a switch case statement. Let's say vehicle type. And inside the switch, I'm gonna add a case statement for by truck. If the vehicle type is by truck, then call my truck dot start transportation. Case, if it is by ship, then let's call my ship dot start transportation, just like that. And let's create an instance of the transportation factory class and call its function. Here, let me say, let my product is equal to transportation factory. In the next line, I will just call the start transportation function. And for the parameter, I will say, let's say by truck, and hit run. It works. Good. Now, suppose our company also wants to have a cargo plane or transportation. That means we need to add a new transportation type. So our code needs modification, which is not good for open-close principle. But still, let's add the new transportation type for cargo planes and see what modification we are gonna make for this. First, let's add another case statement for cargo planes into enum. I'm gonna say case by plane. Also, let's add a class for the plane. And let me copy this function and paste it in plane. Here I will just say transported by plane. And in the transportation factory, I will also create another property for my plane, and this will be the instance of plane class. Also, inside the switch case statements, we have to create another case for by plane, and we're gonna call my plane dot start transportation. So here, let's try to call the by plane and hit run. It works. As you can see, guys, when we want to add a new transportation type, we need to make a couple of modifications in the code base. The open-close principle doesn't like that. It's time to make our code OCP friendly. I will remove the enum and the body of our transportation factory. Let's delete this, and also I will delete all of this. just like that. Now I will add a protocol and apply this protocol to each vehicle class. Here at the most top, let's say protocol transportation, and let me copy this function definition and paste it into protocol. Also, I will apply this protocol into these classes, just like that. Now in the transportation factory, let's also add the start transportation function, and this time its parameter will be target vehicle and the type will be our transportation protocol. Inside the function, just call the target vehicle dot start transportation. Now when we call the start transportation function, we need to pass an instance of our target vehicle. Here, instead of this, I will just say plain instance, and let's hit run. So the parameter name will be target vehicle, not vehicle type, sorry, and let's hit run again. And it works. Good. If we want to add another transportation type, it's okay. There is no need for making changes in the transportation factory class. Let me add another vehicle, which is a, let's say, train. Here, I'll just say class train, and this will conform to our transportation protocol. And inside the train class, let me copy this function and paste it. And in the print statement, I will say transported by train. And here, let me pass the train instance, just like that. Let's hit run, and it still works. Here, when we call the start transportation function, we need to pass an instance of the vehicle. Passing an instance each time may not be a good idea. We can also add dependency injection into transportation factory class to make our code better. So let's do that. Here in the transportation factory class, I will just create a variable called, let's say, target vehicle, and its type will be transportation. Let's make it optional, and I will also create an initializer for that transportation factory class. And let me just copy this definition and paste it over here. Inside the initializer, I would say self.target vehicle is equal to target vehicle. And in the start transportation function, we don't need this parameter anymore. Just delete it, and here I will just try to unwrap our target vehicle property. For that, I will say guard let target vehicle is equal to target vehicle, else just basically return. And if our target vehicle is not nil, then just say target vehicle dot start transportation. So here, when we initialize this transportation factory class, we also need to pass our instance. Let's say, let me copy this train and paste it over here, and also let me remove this because we don't have any parameter for this function anymore. And let's hit run. It still works. Awesome. Well, that's it for this chapter. I hope it was useful for you. Please do subscribe if you have not yet. See you in the next one. Goodbye.